On the 18th of June, 2020, fifth year, when scientists extracted ancient DNA from a fossilized skull in northeastern China, they discovered something that made archaeologists worldwide stop and turn their attention to one remote place in the Altai Mountains of Russia. The mysterious Denisova Cave holds secrets that completely change our understanding of who our ancestors were. And what was revealed explains many things happening in science today and forces us to rewrite the entire history of human evolution. Just months ago, international teams published groundbreaking findings confirming what many suspected but could not prove for 15 years. Strange bone fragments found in this small Altai cave were not Neanderthals or modern humans, but belonged to an entirely different species that lived alongside our ancestors, interbred with them, and then mysteriously vanished. What makes this shocking is not just that another human species existed, but that their DNA is still present in modern Asian populations, which means each of us might carry traces of these mysterious beings in our genes. Archaeologists working in Denisova Cave discovered more than 20 bone fragments and teeth belonging to these enigmatic people, and each finding brought more questions than answers. Who were they? Where did they come from? Why did they disappear? And, most importantly, what were they doing in this particular place in the Altai Mountains? Few people know this cave has been hiding secrets far longer than anyone imagined, and that the discovery story began not in 2008 when the first Denisovan bone was found, but many decades earlier when Soviet scientists first entered the dark passages of this ancient place and realized they had found something extraordinary.
And it all began many years ago, in a time when the USSR was at its height, when teams of dedicated researchers ventured into remote Siberian corners, searching for clues about our past, having no idea they were about to uncover one of the greatest mysteries in human evolution history. Denisova Cave is located in the Altai Mountains in southern Siberia, in a region stretching across Russia, Mongolia, China, and Kazakhstan. And for thousands of years, this area has been considered sacred by indigenous peoples who believed these mountains were a gateway between the physical world and the spiritual realm. The Altaians, Kazakhs, Khakas, and Tuvans have long revered the Altai as a place of powerful spiritual energy, as the dwelling of ancestral spirits, and as the birthplace of shamanism itself. Their legends spoke of mysterious beings who once lived in these mountains, of ancient wisdom hidden in caves and peaks, and of forces modern people could barely understand. The cave sits in the Anhui River Valley, at the foot of sacred peaks, surrounded by rugged cliffs and dense forests that have witnessed countless generations of human activity, from prehistoric hunters to medieval nomads to Soviet archaeologists. In the 1970s, when Russian scientists first began systematic excavations in Denisova Cave, they discovered this was not just any archaeological site. It was a place continuously inhabited for an extraordinarily long period, with cultural layers dating back 125,000 to 180,000 years. The cave consists of several chambers and galleries, each containing its own secrets, its own sediment layers that preserved not only stone tools and animal bones, but something far more precious: the remains of people who once called this place home. What made Denisova Cave special, even before discovering the Denisovans, was the sheer richness of its archaeological record. 22 distinct strata had been identified, containing tens of thousands of artifacts, telling the story of human cultural evolution from the Middle Paleolithic through the Bronze Age and medieval period. The unique temperature and humidity conditions inside created a perfect preservation environment, allowing organic materials, including ancient DNA, to survive for tens of thousands of years, when elsewhere they would have decomposed completely. But what happened next changed everything. When a small bone piece, no bigger than a fingertip, was discovered in layer 11, and scientists examining it had no idea they were holding the key to understanding a chapter of human history that had been completely unknown. In 2008, on an ordinary summer day that would later be marked as one of the most important dates in paleoanthropology, a team of Russian archaeologists working in the eastern gallery of Denisova Cave unearthed a tiny fragment of a juvenile finger bone from a layer dated between 48,000 and 30,000 years ago. At first glance, it seemed like just another piece of human remains, similar to dozens of other bones found in the cave over the years. But something about this fragment caught the researchers' attention, and they decided to send it for DNA analysis. When results came back from the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, scientists could hardly believe what they were seeing. The mitochondrial DNA extracted from the bone did not match Neanderthals, did not match modern humans, but represented something entirely different. A genetic lineage that had diverged from our common ancestors hundreds of thousands of years ago. One researcher who first examined the genetic data later recalled, "We ran the tests again and again, thinking there must be a mistake, but every time we got the same result. This was not a Neanderthal. This was not a modern human. This was something we had never seen before." The scientific community reacted with excitement and skepticism. How could an entirely unknown human species have existed without leaving any trace in the archaeological record, without being mentioned in any textbook, without anyone even suspecting its existence? As a result, this mysterious hominin was given the name Denisovan, after the cave where it was found. And suddenly, a place known only to a small circle of Russian archaeologists became famous throughout the world. Within months, international teams descended upon the Altai region, eager to learn more about these enigmatic people. And with each new excavation, with each new bone fragment analyzed, the picture became more complex and fascinating. The finger bone, catalogued as Denisova 3, became one of the most studied specimens in paleoanthropology, subjected to the most advanced genetic analysis techniques, and it revealed not just one secret, but many. It showed that Denisovans had not only coexisted with Neanderthals in the same cave, but had also interbred with them, creating hybrid offspring whose genes carried traces of both species. And everyone realized this was only the beginning. The roots of the Denisovan presence in the Altai Mountains stretch back into a past so distant it challenges imagination. Archaeological evidence suggests hominins were living in this region as far back as 280,000 years ago, during a time when climate, landscape, and even continental positions were different from today. To understand how these people came to inhabit Denisova Cave, we must picture a world in the grip of the Ice Age, when massive glaciers covered much of the northern hemisphere, when sea levels were lower, and when land bridges connected regions now separated by water. During this period, groups of archaic humans were migrating across Eurasia, following herds of mammoths, woolly rhinoceroses, and ancient horses, searching for shelter in caves and river valleys, developing increasingly sophisticated stone tools and social structures. The Altai region, positioned at the crossroads of several migration routes, became a meeting place for different hominin populations. Groups moving from the west brought Neanderthal genes and Mousterian stone tool technology, while groups from the east carried different genetic lineages and cultural traditions. Denisova Cave, with its spacious chambers, protection from harsh weather, and proximity to the river where animals came to drink, must have been attractive for these early people, offering everything needed for survival: shelter, water access, hunting grounds, and raw materials for tool-making. The earliest inhabitants left behind simple stone implements, bones of animals they hunted and butchered, and charcoal from hearths where they cooked food and gathered for warmth during long winter nights. But these were not primitive savages living in darkness. Recent discoveries show that even the earliest Denisova Cave populations possessed remarkable skills and knowledge, including the ability to work with bone and ivory, to create decorative objects, and possibly even to use language to communicate complex ideas. In Layer 11, the same layer where the famous finger bone was discovered, archaeologists found something astonishing. A needle made from bird bone, measuring 2 3/4 inches long, with an eye for thread, dated to approximately 50,000 years ago. This needle, one of the oldest ever discovered, suggests Denisovans were capable of sophisticated craftsmanship and were making clothing, possibly decorated with beads and ornaments. Sometime around 50,000 years ago, on a day that left no written record but whose consequences can still be detected in our DNA, a moment occurred in or near Denisova Cave that would later be described by scientists as one of the most significant events in human evolutionary history: the meeting and interbreeding of Denisovans with Neanderthals. Imagine the scene. The cave interior illuminated by flickering firelight, shadows dancing on stone walls where ancient petroglyphs had been carved by generations of inhabitants. The sound of voices speaking in languages we can never recover, and the presence of people who looked different from each other in subtle but unmistakable ways. The Neanderthals who arrived in the Altai would have been stocky and powerfully built, with prominent brow ridges and bodies adapted for life in cold climates, carrying stone tools and hunting techniques perfected over hundreds of thousands of years in Western Eurasia. The Denisovans, whose exact physical appearance remained a mystery until very recently, would have had their own distinctive features. Recent analysis of the Dragon Man skull from China, now believed to be Denisovan, suggests they had large, robust skulls with wide faces and prominent cheekbones, adapted for the harsh Ice Age Asian environment. When these two groups met, they did not immediately fight or flee. Instead, evidence suggests they coexisted in the cave for extended periods, possibly even living together in the same chambers, sharing resources and knowledge. And then something happened that left its mark in the genetic record. A Denisovan individual and a Neanderthal individual formed a relationship, perhaps born of attraction, perhaps of alliance between groups, perhaps of circumstances we can never fully understand. The result of this union was discovered thousands of years later. A bone fragment found in Denisova Cave that, when analyzed, revealed one of the most extraordinary genetic profiles ever recorded. The individual, nicknamed Denny, was a first-generation hybrid, with a Neanderthal mother and a Denisovan father. One scientist who worked on analyzing Denny's DNA said, "When we first saw the results, we thought it was contamination. Nobody expected to find a direct offspring of two different hominin species." This discovery proved that interbreeding between different hominin species was not a rare accident, but a regular occurrence. Episode 1. In the 1980s, nearly 3 decades before the discovery of the Denisovan finger bone, a milk tooth was found in layer 22.1 of the central chamber, and for years it sat in storage, catalogued and forgotten, until new DNA analysis techniques became available and scientists decided to re-examine it. When they extracted genetic material from this tooth, they discovered it belonged to a Denisovan individual who lived approximately 100,000 years ago, pushing back the known timeline of Denisovan occupation in the cave by tens of thousands of years. Episode 2. In the Southern Gallery, archaeologists uncovered evidence of sophisticated cultural activities that challenged previous assumptions about archaic human cognitive abilities. They found remains of carefully constructed hearths with stone surrounds, pits dug into the floor for food storage, and even remains of wooden stake fences that had been erected to divide the cave interior into separate living areas. These discoveries showed that the inhabitants, whether Denisovan or Neanderthal, were not simply sheltering in a natural cavity, but were actively modifying their environment, creating what could be called homes, with different areas for different activities. Episode 3. A woman who worked as a guide at the archaeological site shared her personal story. My grandmother used to tell me that our ancestors spoke of people who lived in the mountains long before any tribe we know of. We thought these were just legends. But when the scientists found the bones, when they proved that other kinds of humans had really lived here, it changed how we saw our own history. My grandmother cried when I told her. She said the ancestors had been telling the truth all along. This testimony shows how the scientific discoveries resonated not just in academic journals, but in the lives of people who had maintained spiritual connections to the Altai Mountains for generations. Episode 4. Perhaps the most dramatic development came when researchers discovered that Denisovan DNA is still present in modern human populations across Asia and Oceania, with some Papua New Guinean populations carrying up to 5% Denisovan ancestry. This meant that the genetic legacy of people who lived in Denisova Cave had not vanished when their species went extinct. It had been passed down through countless generations, surviving to this day in millions of people. As the significance of the Denisova Cave discoveries became clear, a remarkable effort began to understand and, in some cases, to hide or restrict the full implications of what had been found. For decades, the site had been excavated primarily by Russian teams, working with limited resources and little international attention. But after 2010, when the first papers about Denisovan DNA were published, everything changed, and the cave became a focal point of scientific interest from around the world. However, gaining access to the site and the precious bone fragments stored in Russian institutions proved challenging for many international researchers who faced bureaucratic obstacles, concerns about specimen preservation, and sometimes reluctance from authorities cautious about sharing materials that had become objects of national pride. Some scientists who attempted to obtain samples for independent analysis reported frustration and delays, with one researcher confiding, "It took us 3 years just to get permission to examine one small bone fragment. By then, other teams had published their findings, and we had lost our chance to contribute." There were also questions about what other materials might be in storage at Russian institutions, what other bones and artifacts from Denisova Cave had been found but not yet fully analyzed or published. Why this was to be hidden, or at least closely controlled, became a subject of speculation. Was it simply normal scientific caution and the desire to ensure Russian researchers received credit for their work, or were there deeper concerns about the implications of finding evidence that multiple human species had coexisted and interbred? Meanwhile, at the cave itself, efforts continued to extract as much information as possible from the sediments before time, weather, and human activity could destroy what remained. Archaeologists worked carefully, screening every shovelful of dirt, collecting samples for DNA analysis, documenting each layer with meticulous precision. The cave deposits contained not just bone, but also plant remains, pollen grains, and microscopic traces of ancient human activity that could be detected using cutting-edge techniques. How people continued to search for the truth, despite these obstacles, became a testament to human curiosity. New methods were developed to extract DNA not just from bones, but from the sediment itself, which retained genetic material from individuals who had lived in the cave even when their bones had decomposed completely. What you are about to hear explains everything that happened then and is happening now in paleoanthropology. This was kept secret, not deliberately hidden, but simply unknown, for 15 years. And only recently, in June of 2025, did the final piece of the puzzle fall into place.
In northeastern China, in a place far from Denisova Cave, but connected to it by ancient migration routes and shared ancestry, a fossilized skull had been discovered decades earlier and had puzzled researchers for years. This skull, nicknamed the Harbin Skull or Dragon Man, was massive and heavily built, with features that did not fit neatly into any known human species, too robust for modern humans, too large for Neanderthals, with peculiarities of shape and structure that suggested something different. For years, scientists attempted to extract DNA from this skull using conventional methods, drilling into the dense bone, trying to access regions where DNA is sometimes preserved, but again and again, they failed. Then, in a breakthrough moment, a research team led by Professor Chao Mei Fu from the Chinese Academy of Sciences tried something different. Instead of sampling the bone itself, they carefully scraped away some of the hardened dental calculus, the mineralized plaque that had formed on the teeth during the individual's lifetime. What they discovered exceeded all expectations. The dental calculus, which had protected ancient DNA for tens of thousands of years in its rock-hard matrix, yielded enough genetic material to confirm what many had suspected. The Harbin Skull belonged to a Denisovan.
This meant that, after 15 years of knowing Denisovans only from tiny bone fragments and teeth from Denisova Cave, scientists could finally see what these mysterious people had looked like. Their large, robust skulls, their wide faces adapted for cold climates, their powerful jaws designed for a diet that may have included tough plant materials and meat. Professor Fu, speaking to reporters after the announcement, said, "I genuinely believe that we have unveiled some of the mysteries surrounding this group. After 15 years, we now possess the first Denisovan skull. And you know what? This explains what is happening right now in laboratories and excavation sites around the world, as researchers rush to re-examine other fossils from Asia that might also be Denisovan." Aspect 1. The genetic analysis of both the Denisovan material from the Altai and the DNA extracted from the Dragon Man skull revealed specific details about how these people were related to other hominin species. Mitochondrial DNA, which is inherited only from the mother, showed that Denisovans had diverged from the Neanderthal lineage approximately 400,000 years ago, while both had separated from the lineage leading to modern humans approximately 600,000 years ago. What this means in simple words is that Denisovans, Neanderthals, and modern humans all descended from a common ancestor who lived in Africa more than 500,000 years ago, and as these populations spread across Eurasia, they evolved separately, adapting to different environments and developing different physical and genetic characteristics. The connection with known facts became clear when researchers compared ancient DNA sequences with genetic data from present-day populations. They found that people living in Papua New Guinea, Aboriginal Australians, and some East Asian populations carry significant amounts of Denisovan ancestry, confirming that interbreeding had occurred not just in the Altai, but probably in multiple locations across Asia. Aspect 2. The timeframes during which Denisovans occupied the Altai region stretch across an enormous span. From approximately 200,000 years ago, when early evidence of hominin activity in Denisova Cave begins to show genetic signatures consistent with Denisovans, through to approximately 50,000 years ago, when the last clear evidence of their presence appears. Geographical features of the Denisovan range have only recently begun to be mapped, with evidence from genetics, fossil finds, and archaeology suggesting they inhabited a vast territory from Siberia through Central Asia to China, and possibly as far south as the Philippines and Indonesia. Aspect 3. The people involved in these discoveries form a fascinating international network of researchers, from the Russian teams who have been excavating Denisova Cave since the 1970s, through the German scientists at the Max Planck Institute who pioneered the DNA analysis techniques, to the Chinese researchers who finally revealed the identity of the Dragon Man's skull. Aspect 4. The consequences for society and country have been profound, particularly in Russia and China, where the discoveries were made. Evidence 1. Documentary evidence from the archaeological excavations at Denisova Cave includes detailed stratigraphic records showing 22 distinct layers of sediment, each dated using multiple techniques, including thermoluminescence dating of minerals and radiocarbon dating of charcoal, providing a chronological framework that spans more than 150,000 years. The dates show that Layer 11, where the original Denisovan finger bone was found, dates to approximately 48,000 to 30,000 years before present, while deeper layers contain evidence of occupation extending back to 125,000 or even 180,000 years ago. The initial 2010 Nature paper announcing the discovery of Denisovan DNA was authored by a team including Johannes Krause, Chao Mei Fu, and Svante Pabo from the Max Planck Institute, along with Russian colleagues including Anatoly Derevianko from the Institute of Archaeology and Ethnography in Novosibirsk. Evidence 2. Testimonies from scientists who worked on the project provide human context to the dry facts of scientific papers. Their stories, told in interviews and conference presentations, reveal the excitement of discovery, the frustration of technical challenges, and the satisfaction of solving a mystery that had eluded humanity for thousands of years. Evidence 3. Physical clues found in the cave go beyond just bones and include the remarkable 50,000-year-old needle made from bird bone, demonstrating sophisticated craftsmanship, plus stone tools representing multiple cultural traditions, animal bones showing butchery marks and cooking, and chemical traces in the sediment revealing the presence of ancient DNA. Evidence 4. Indirect confirmations come from the discovery that modern human populations across Asia and Oceania carry Denisovan genetic ancestry, which would be impossible if Denisovans had never existed, or if they had never interbred with modern humans. Coinciding events in other places include the discovery of fossils in China that show Denisovan features, the finding of a Denisovan jaw fragment in Tibet showing adaptations to high altitude, and genetic evidence suggesting Denisovans reached as far as island Southeast Asia. Evidence 5. Modern findings continue to accumulate, with new technologies confirming earlier results and adding fresh details. What has been discovered recently includes the groundbreaking extraction of DNA from the Dragon Man skull in 2025. Events of recent years have brought the story of Denisova Cave and the Denisovans back into the headlines multiple times, showing that this is not just ancient history, but an actively developing story with relevance to current understanding of human biology and evolution. What has happened in the last 2 or 3 years includes the publication in June 2025 of the papers announcing the extraction of DNA from the Dragon Man skull, which occurred after years of failed attempts and represented a major technical breakthrough. On the 18th of June 2025, the research was officially announced to the world, triggering a wave of media coverage and scientific commentary. How this is connected to the main topic is direct. The Dragon Man skull provides the physical face to go with the genetic evidence from Denisova Cave, showing that Denisovans were not just a set of DNA sequences, but real people with distinctive appearances who lived and loved and struggled to survive in Ice Age Asia. You have probably heard about the increasing use of ancient DNA technology in archaeology and forensics, and the Denisovan discoveries are at the forefront of this revolution. Events of recent months have included scientific conferences where researchers from around the world gather to discuss the latest findings from Denisova Cave and other sites, sharing data and debating interpretations. Fresh facts include the realization that the cave served as a meeting place where Denisovans, Neanderthals, and eventually modern humans all spent time, sometimes separately and sometimes together, creating one of the most complex archaeological records of archaic human behavior anywhere in the world. Interest from authorities and scientists has grown to the point where Denisova Cave is now considered a site of global importance, attracting funding from multiple countries and being discussed as a potential UNESCO World Heritage Site. And this cannot be just a coincidence. The fact that multiple independent lines of evidence from genetics, archaeology, anthropology, and dating techniques all point to the same conclusion about Denisovan existence and importance. Personal address to you, the viewer. You can see this yourself if you follow scientific news sources, where stories about ancient DNA and human evolution appear regularly. Each of us can notice how our understanding of human origins has changed, even in just the last decade or two. This concerns your children and grandchildren because the Denisovan genes that entered the human population tens of thousands of years ago are still present today. International parallels to the Denisova Cave discoveries reveal that the pattern of archaic human species coexisting and interbreeding was not unique to the Altai, but occurred across Eurasia during the Pleistocene.
Case 1. In China, beyond the Dragon Man skull, other fossils have been discovered that show features consistent with Denisovan morphology, including jaw fragments from Tibet that demonstrate adaptations to high-altitude living and suggest that Denisovans had spread across a vast range of environments. This surprising coincidence, finding Denisovan remains separated by thousands of miles, indicates that these people were successful and adaptable, not confined to a single cave or region, but ranging widely and exploiting different ecological niches. The same patterns of genetic mixing appear in analysis of modern human populations, with Southeast Asian, Melanesian, and Aboriginal Australian groups all showing Denisovan ancestry that must have been acquired through interbreeding somewhere along the migration route of early modern humans leaving Africa. Case 2. Looking at another time period, researchers have found evidence of similar mixing between Neanderthals and modern humans in Europe and the Middle East, showing that the interbreeding seen at Denisova Cave was part of a larger pattern of genetic exchange whenever different hominin groups encountered each other. Similar circumstances of cave occupation, tool use, and cultural development appear at Neanderthal sites in Europe, suggesting that despite genetic differences, the behavior and cognitive abilities of Neanderthals, Denisovans, and early modern humans were remarkably similar. Case 3. Other researchers studying ancient hunter-gatherer populations in Siberia have uncovered evidence of high mobility and long-distance connections, with individuals from the Altai region showing genetic links to populations thousands of miles away. Who else studied this question includes teams from the University of Tübingen, the Max Planck Institute for Evolutionary Anthropology, Fudan University in China, and numerous other institutions. What conclusions they reached were that the populations of Ice Age Eurasia were not isolated groups living in ignorance of each other, but were part of interconnected networks with regular long-distance movement of people, genes, ideas, and technologies. The dramatic conclusion becomes inescapable. Is it really not a local phenomenon confined to one cave in Siberia, but part of something bigger, a fundamental characteristic of human behavior throughout prehistory? Explanations and theories for why Denisovans existed as a separate species and what led to their eventual disappearance have been proposed by scientists from multiple disciplines, each offering different perspectives on these fundamental questions. For an event as complex as the extinction of an entire human species, causes and consequences must be examined from multiple angles. Climate change, competition with other hominins, disease, demographic factors,
and the gradual absorption of Denisovan populations into expanding modern human groups through interbreeding. Theory 1. The official version favored by most paleoanthropologists is that Denisovans evolved in Asia from an earlier hominin population, possibly Homo erectus or another archaic species, and developed their distinctive genetic and physical characteristics through hundreds of thousands of years of evolution in relative isolation. What authorities and scientists say, based on careful analysis of genetic distances and fossil evidence, is that Denisovans represented a separate evolutionary lineage that diverged from Neanderthals approximately 400,000 years ago. The official explanation for their disappearance is that as modern humans expanded out of Africa and into Asia beginning around 60,000 years ago, they gradually replaced or absorbed the Denisovan populations through a combination of competition for resources and genetic mixing. Theory 2. An alternative viewpoint, proposed by some researchers, is that the distinctions between Denisovans, Neanderthals, and modern humans have been overstated, and that these were not truly separate species, but rather populations within a variable human species that maintained some genetic distinctiveness while still being able to interbreed freely. What does not fit in the official version, according to this view, is the extent and frequency of interbreeding revealed by genetic studies. Theory 3. Perhaps the truth is in the middle, recognizing that Denisovans were genetically distinctive and had evolved separately for hundreds of thousands of years, making them different enough to be classified as a separate species for practical purposes, while acknowledging that the boundaries between hominin species were permeable and that genetic exchange was possible when populations encountered each other. What both sides acknowledge is that Denisova Cave provides unique evidence of this complex reality. Historians who specialize in the Paleolithic period have weighed in on what the Denisova Cave discoveries mean for our understanding of Ice Age societies and human cultural evolution. What they say about the event and the people is that the evidence from the cave demonstrates levels of cultural sophistication and behavioral complexity in archaic humans that previous generations of scholars would have found surprising. Historical context provided by these experts emphasizes that during the period when Denisovans occupied the cave, roughly 50,000 to 200,000 years ago, they were living through enormous climatic changes, including glacial advances and retreats that would have dramatically affected the landscape. Subject matter experts from different scientific fields have contributed their specialized knowledge. Scientists focusing on genetics have revealed the complex web of relationships between Denisovan, Neanderthal, and modern human populations. Anthropologists studying human fossils have worked to reconstruct what Denisovans looked like, with the Dragon Man skull finally providing concrete evidence of their robust build and large features. Archaeologists who understand stone tool technologies and cave stratigraphies have shown how Denisovan tool-making abilities evolved over time and compared them to contemporary Neanderthal and modern human technologies. Their professional analysis demonstrates that Denisovans were capable of producing sophisticated implements, including the bone needle that represents one of the earliest examples of this technology anywhere in the world. Statistics and numbers from genetic studies reveal specific data about population sizes, migration rates, and timing of interbreeding events. For example, analysis suggests that the interbreeding between Denisovans and the ancestors of modern Melanesians occurred approximately 40,000 to 50,000 years ago, probably in Southeast Asia. Present-day Papua New Guinean populations carry approximately 4 to 6% Denisovan ancestry on average, while other Asian populations carry smaller but still detectable amounts. Mathematics shows that the amount of genetic variation detected among the few Denisovan specimens from the cave is remarkably high, suggesting that the Denisovan population size may have been substantial. According to statistics compiled from multiple studies, Denisovan genes are now found in approximately 300 million to 400 million people worldwide, primarily in Asia and Oceania. Even skeptics admit that the evidence for Denisovan existence and their interbreeding with other human species is now overwhelming. Story 1 begins with an ordinary person, a woman from Papua New Guinea who participated in a genetic study and learned that she carries approximately 5% Denisovan ancestry, one of the highest percentages found in any living person. Her experience of discovering this connection to an ancient human species that went extinct 40,000 years ago, but left its mark in her DNA, was deeply emotional. She described feeling a sense of connection to the deep past, imagining her ancestors meeting and forming relationships with Denisovans somewhere in Southeast Asia during the long migration that eventually brought humans to New Guinea. How it affected her life was subtle but meaningful. She began studying archaeology and human evolution, wanting to understand more about the people whose genes she carried. And she has spoken at schools in her community about the importance of preserving archaeological sites. What she thinks about it now is that it has given her a broader perspective on what it means to be human and on the commonality of all people, despite surface differences. Story 2 takes a more dramatic turn with the experience of scientists who excavated Denisova Cave and handled the actual bone fragments of Denisovans, sometimes finding themselves overwhelmed by the realization that they were touching the remains of people who had lived impossibly long ago. A more difficult situation arose when disputes over access to specimens threatened to derail research projects, and when the pressure to publish groundbreaking results led to intense competition between research teams. Hardships included working in the cave under difficult conditions, spending long hours screening sediment in cold and cramped quarters, dealing with bureaucratic obstacles to getting permits and funding. How they coped was through dedication to the scientific process and support from their research teams. Story 3 involves an inspiring elderly person, a Russian man who had worked as a young archaeologist on early expeditions to Denisova Cave in the 1980s, long before the discovery of Denisovan DNA, and who lived to see his life's work vindicated by modern discoveries. His wisdom included decades of excavating in Siberia under Soviet conditions when resources were limited. What he says to the young generation is to respect the past, to remember that archaeology is not just about making sensational discoveries, but about carefully building knowledge. Layers of meaning in the Denisova Cave story go far beyond the immediate facts about bones and DNA, touching on profound questions about human nature, identity, and our place in the natural world. Surface-level understanding tells us simply that another hominin species existed, lived in Siberia and across Asia, and went extinct thousands of years ago. Symbolic-level interpretation reveals that this story challenges the notion of human uniqueness and forces us to confront the reality that we are not the product of a single pure lineage, but the result of mixing between multiple species, carrying within us the genes of peoples who lived and loved in worlds we can barely imagine. What this says about us as humans is that our boundaries are more permeable, our history more complex, and our connections to other forms of life deeper than we might have thought. About our society and country, the Denisovan discoveries speak to the importance of international scientific collaboration, showing that understanding our shared human heritage requires cooperation across national boundaries. For Russia specifically, the cave represents a source of pride and international recognition, placing the Altai region on the map as a site of global importance. About human nature, the evidence of interbreeding between species suggests that our ancestors were open to relationships across what we would now consider profound biological differences, perhaps teaching us something about tolerance and the recognition of shared humanity, even in those who appear different. Historical-level reflection reminds us of lessons that must not be forgotten. The archaeological record shows that multiple human populations coexisted for thousands of years, sometimes peacefully sharing territories and resources, as the evidence from Denisova Cave suggests. What we must remember is that the bones found in Denisova Cave represent real people who faced real challenges: harsh climates, dangerous animals, the constant struggle for food and shelter, and who nevertheless found time to craft beautiful objects like the bone needle. Personal-level application of these lessons means recognizing that each of us carries within our DNA the legacy of countless ancestors stretching back through time, including possibly genes from Denisovans or Neanderthals. Wisdom for grandchildren that emerges from the Denisovan story includes teaching them that history is always more complex than simple narratives suggest, that science can reveal truths about the past that were completely unsuspected. Perhaps this story is trying to teach us something about memory, truth, and who we are. Literally yesterday, on the 26th of November 2025, researchers working with Denisovan genetic data published new findings about how these ancient genes continue to affect present-day populations, revealing specific genetic variants that influence immune response and adaptation to different environments. This morning in the news, if you follow scientific journals and archaeology websites, you can find ongoing discussions about the Dragon Man skull and what the DNA extracted from it reveals about Denisovan physical appearance and their spread across Asia. This week, excavations continue at Denisova Cave, where international teams are working through the winter months, carefully extracting sediment samples that will be analyzed for ancient DNA, pollen, and chemical traces of human activity. Specific facts that viewers can verify themselves include the publication in major scientific journals like Nature and Science of papers about Denisovan genetics, the display of Denisovan-related exhibits in natural history museums around the world, and the ongoing excavations at the Altai site. What is happening with the topic now is a surge of interest in re-examining fossils from across Asia to determine whether they might be Denisovan, using the Dragon Man skull as a reference point. New research, excavations, and documents are emerging regularly as deeper layers of Denisova Cave are reached, as more fossils from China and Southeast Asia are analyzed, and as genetic studies of modern populations reveal more details about where and when Denisovan ancestry was acquired. Public interest remains high, with documentaries being produced, museum exhibitions being mounted, and educational programs teaching students about the complex history of human evolution revealed by the Denisovan discoveries. Development dynamics show that the situation is changing rapidly in the direction of greater understanding. What was completely unknown 15 years ago is now textbook material. New discoveries on the way include plans to conduct more extensive excavations in promising areas of the cave that have not yet been fully explored. Public reaction to the Denisovan discoveries has been overwhelmingly positive, with people expressing fascination at learning that multiple human species once coexisted. Discussions and debates continue in academic circles about how to classify Denisovans and what their discovery means for concepts of species boundaries. International response has been strong, with scientists from every continent contributing to the research effort. Consequences and significance of the Denisovan discoveries extend across multiple domains, affecting scientific understanding, cultural narratives, and even practical applications in medicine and genetics. For Russia, how this affected the country has been profound. The Altai region has gained international recognition as a site of world importance for human evolutionary studies, attracting researchers, funding, and attention that benefits local scientific institutions. What changed in society includes a growing awareness that Siberia was not a peripheral region in human prehistory, but a central meeting place where different human populations encountered each other. Lessons for the future include the importance of preserving archaeological sites, supporting long-term research projects, and maintaining international scientific collaboration despite political tensions. Russia has gone through this process of discovery and recognition, and the country can take pride in the work of Russian archaeologists who maintained excavations at Denisova Cave for decades under difficult conditions. For people around the world, how this affects ordinary individuals might seem abstract, but it has real implications. The discovery that many Asians carry Denisovan genes has led to research on how these ancient genetic variants affect health, disease resistance, and adaptation to different environments. Changes in society's consciousness include a shift away from thinking about human races as fundamentally different categories toward recognizing that all human populations are closely related and carry mixed ancestry from multiple sources. For history, and how textbooks are being rewritten, the impact is substantial. Every major textbook on human evolution published in the last 10 years includes a section on Denisovans, and museum exhibits around the world have been updated. New understanding of the past includes recognition that Asia was home to multiple archaic human species, that these species were sophisticated and capable of complex behavior. For the future, what this means for our children and grandchildren is that they will grow up with a more accurate and nuanced understanding of human origins. What conclusions need to be drawn include the importance of preserving genetic diversity in human populations and respecting archaeological heritage sites. And despite everything we have learned about extinctions and the disappearance of other human species, we see reasons for hope in the resilience and adaptability that allowed our ancestors to survive through enormous challenges. What we can do ourselves, as individuals living today, in response to the lessons of the Denisovan discoveries might not be immediately obvious, but there are meaningful ways to connect with this aspect of our shared human heritage. Preserving memory begins with the simple act of learning about and remembering the story of Denisova Cave and the people who lived there tens of thousands of years ago. By reading about archaeology and human evolution, by visiting museums that display Paleolithic artifacts, by teaching ourselves and our families about the deep history of humanity. Remember and pass on stories to younger generations, telling children and grandchildren about the remarkable discoveries in Siberia and what they reveal about human nature and history. Tell them about the bone needle crafted 50,000 years ago by hands as skilled as ours, about the people who survived Ice Age winters in mountain caves, about the meetings between different human groups that led to genetic mixing and ultimately to the diversity we see today. Searching for truth involves maintaining a healthy curiosity about the past and a willingness to accept new evidence even when it challenges previous beliefs. Be interested in history not just as a collection of dates and names, but as a living connection to people who faced real challenges. Do not blindly believe the official version of any historical narrative, but seek out multiple sources and understand that knowledge evolves as new discoveries are made. Personal position toward the past includes developing a sense of respect for our ancestors, recognizing that they were not primitive or inferior, but were intelligent, creative people. Application in life might mean approaching encounters with people from different backgrounds with the knowledge that we are all closely related, all carrying mixed ancestry, all part of one human family. Public action that individuals can take includes supporting archaeological research through donations to museums and research institutions, visiting and respecting archaeological sites, and advocating for protection of cultural heritage locations. Discuss with others the implications of discoveries like those from Denisova Cave, sharing the story and encouraging others to learn about human evolution. Passing on wisdom to younger generations is perhaps the most important thing we can do. Teaching young people to value history, to respect scientific inquiry. Connection of generations is strengthened when older people share their knowledge with youth. Each of us is a keeper of memory, and if we remember, the truth will never disappear. We started with what happened on the 18th of June, 2025, when DNA extracted from the Dragon Man skull finally revealed the face of a Denisovan and connected discoveries from China to the bone fragments found decades earlier in a cave in the Altai Mountains. Now we know the whole story, or at least as much as current evidence allows. Short summary of the path we have traveled. From the initial discovery of mysterious DNA that matched no known human species, through the gradual accumulation of evidence from bones, teeth, and genetic analysis of modern populations, to the recent breakthrough that allowed us to see what Denisovans actually looked like. Main revelations include the understanding that Denisovans were a widespread and successful human species that ranged across much of Asia, that they possessed sophisticated cultural abilities, including the crafting of bone needles and other complex tools, that they regularly interbred with both Neanderthals and modern humans, and that their genetic legacy persists in millions of people today. Unexpected twists in the story included the discovery of a first-generation Denisovan Neanderthal hybrid individual in the cave, the realization that Denisovan genes provide adaptive advantages to some modern populations, and the revelation that this ancient species left its mark not just in Siberia, but across a vast territory. What remains a mystery includes many questions that future research will need to address. Exactly how many Denisovan populations existed, what their full range was, how their culture compared to that of contemporary Neanderthals and modern humans, and what specific factors led to their extinction as a distinct species. But some documents are still not yet fully published, with specimens in Russian and Chinese institutions that have not been completely analyzed. Hints at hidden knowledge include the probability that more Denisovan fossils exist in museum collections, waiting for someone to examine them with modern techniques. History teaches us that the truth always finds a way to emerge from the darkness of the past. Maybe not immediately, maybe not in the lifetime of those who first sought it, maybe after years of patient excavation, decades of careful analysis, but it comes to light eventually. We cannot change the past, but we can remember, honor, and learn. And recently, information appeared about another mystery in the Altai Mountains. Petroglyphs and rock carvings dating back thousands of years, showing symbols that connect to shamanic traditions still practiced in the region. Time will tell. We remember.